Okay, we're going to look at this next geometry reason, which is the angle at the center of a circle. The angle that's formed at the center of a circle is it's twice the size of the angle at the circumference. Well, that's the reason. There's a proof for it, but we're just going to use it today. It can take different forms. This thing can go anywhere on the outside. It can even come way down here, so you have to kind of get your mind around that the angle could be all over the place. Like, look here. You could have the angle over here. That angle pointing right over there at the circumference, BAC, is 1/2 the size of that angle BOC. The angle at the center is 2 times the angle at the circumference. So it can look like that. There's some other applications too of it. Let's just take a look here. Here's an angle at the center, BOC. It's 2 times the angle here. If this is 30, that's 60. If that's 40, that's 80. If it's 50 degrees, the angle at the center is 100 degrees. But it can get a little bit weirder too. What if you had a big angle like this? Well, this angle at the circumference is equal to this big angle at the center of reflex angle. So this might be 100 degrees. BOC would be 200 degrees. That's the way it works. The angle at the center is 2 times the angle at the circumference. So you got to take a look out for that. Now they give this another reason. It's called angles in a semicircle. Semicircle means half a circle. Or sometimes it's called angles in a diameter. But this is the reason they like you to use angle in a semicircle. Well, it turns out it's out 90 degrees, but it's really just a version of this, because a straight line right in the center there, it's got an angle of 180 degrees. Well, if the angle at the center is twice as big as the angle at the circumference, then that angle A must be 90, if that's 180. But whenever we see a line going straight across the center of a circle, you can go, oh, it's a right angle triangle. That angle A is 90 degrees. And that's how it works. Now what we're going to do is we got 5 questions that were given in the exercise. I'm just going to go through it and give you a little bit of hints and ideas of how you should go about it. Well, this one's straightforward. It's an angle at the circumference. There's an angle at the center. You just follow the rules. Same with question 2. But question 3, ooh, that looks like a diameter. It looks like a diameter. So you can get at this angle. And then you have to think about all the reasons that you've got in geometry way back to grade 7. Angles in a triangle, exterior angle, all of the parallel line reasons. You need to use all of them. You could use any of those reasons at any time. And there's an exterior angle of a triangle is a real popular one. Okay, well this angle. Oh, this looks interesting. There's that one where you've got an angle at the circumference. Here's an angle at the center. It's just a reflex angle. It's just big. Hey, same thing here. Now this is 120 degrees. If that's 120 degrees and that's a revolution, I could get at this reflex angle. Maybe I could get it that way. Anyways, I didn't give all the answers here. You've got a memo that I'm going to send to you after this. If you're looking at the memo, you should be able to figure out all these questions here pretty good, using that idea that the angle at the center is twice as big. This angle here, B, is twice as big as the angle at the circumference. Okay, there you go.